Hello and welcome to Skills in Automation. My name is Ash and today we are going to talk about calling sub-procedures and functions to make your code more smarter and more manageable. On a high level, sub-procedures or subs for short are macros that hold our lines of code in the VB editor. So we are referring to the code that sits between these two lines, that is this code right here. Now, I'll assume that most of you have worked with VBA projects with a single sub-procedure where the entirety of the code is bundled into one sub-procedure. But as your code becomes larger, you may want to consider splitting up the code into separate sub-procedures or functions and calling those subs or functions from your original sub. Okay, in this video, we will first deep dive into the theory of subs and functions so that we are all on the same page. Then we will convert this existing single sub into separate subs and functions. We will do this Q&A style. I will describe what we want to achieve. I'll pause for a second so that you can think whether we need a sub or function to achieve that task, and then we will build out the code. And lastly, we will look at how to tackle error handling in scenarios where there are multiple layers of sub-procedures. But first, there are many benefits to adopting an approach where we call bits of code from other subs or functions. We will discuss these next. Let's look at 3 benefits of using subs and functions. There are many more, of course. A long piece of code may seem tough to manage. It would prove better to break the code into bite-sized tasks which can be held in separate subs and functions. This reduces the complexity of the design. For example, we have this long and complex sub-procedure, and this is the part where we send out an email. Instead of having this code sitting in this current macro, what we can do is build out a separate sub which runs the same code, and then just call that sub from the main macro. This approach helps distribute the complexity across the project rather than concentrating it all in one place. One benefit of this is that we can now test these individual subs and functions separately, instead of trying to run the full macro each time just to test this send email part, which means we can build our projects in stages, writing individual subs and then bringing them all together at the very end. Next, as we build more and more VBA projects, you will find yourself using the same blocks of code again and again across different projects. For example, I have used this customized find function in different videos. We won't worry about this code at the moment. It basically mimics an XLOOKUP style operation. The point here is that this function is basically plug and play. I can just copy and paste it into different projects as is. So, I'm calling this find function from another macro out here. This at the moment looks very tidy. If I didn't use this function and I wanted to perform the same operation, I would need to type out this code and somehow try and fit it into this macro, which is not easy. Even within the same project, you might find yourself trying to perform similar operations again and again. This is just waste of code. One generic coding principle is dry. That is, don't repeat yourself. So, if you ever feel you're repeating code in a VBA macro, it's an indication that you might need to build out the logic in a separate sub and call that sub multiple times instead of repeating the same code multiple times. So coming back to the find lookup function, we are doing lookups in 2 different places out here. So instead of writing the underlying code twice, we have just created one lookup function and we're calling that function twice. All of this will get more clearer as we work through the example for this video. One last note is on parent subs and child subs. I use this terminology a lot in my videos. It's not really a VBA specific term, rather just common industry jargons. Let's look at a macro from one of my previous videos. So in this macro, we basically perform tasks such as import and export in different steps. Let's look at the code. So I have my main sub out here. I call this the parent sub. This is my command center. I use it to control the flow of the full macro. And I prefer having minimum logic in the parent sub. And from this parent sub, I will call other child subs and functions to perform various tasks. For example, we are calling a sub out here, we're calling a function here, we're calling another function out here, and so on. Notice how I've named my variables and child subs. We will get into the specifics later, but I want to mention that there is an effort to make the code more readable. So here we're calling a function. You can see that it's named as a phrase, and I can understand what it's supposed to do just by reading it. The code for this function is in the supporting module. You can see that there are quite a few complex operations going on out here. But from the perspective of the parent sub, I don't want to see any heavy coding logic out here. Maybe some if statements here and there, but nothing beyond that. The idea is that even a beginner in VBA should be able to look at the parent sub and understand what's going on by reading it like a book. All the complexity is abstracted away in the supporting modules, but the parent sub will give a high-level picture of the end-to-end process. Okay, these were a few of my thoughts on coding with the parent and child sub design. Next, let's deep dive into the theory section. If you're starting out with VBA and you want to build an automation project, you will need to provide a set of instructions or code. This set of code will be contained within a sub procedure, or sub for short. This is the syntax for a sub procedure, but we will keep it simple for now. Let's come to a blank module and build a sub. This keyword sub indicates that we are about to begin writing out a sub procedure. Let's provide a name for the sub. Open close brackets, press enter. The end sub line appears, which indicates the end of a sub. Our code will sit between these two lines. So what can we do with it? Well, let's open a file. We'll call the open method of the workbooks collection object. And I'm just going to paste in the full file path of the file that we want to open. Let's run this macro. And the file opens. Now, there are many ways to executing this sub. We just saw one way where we pushed the play button. Another way would be to call this sub from another sub. Yes, we can do that, and that's actually the core topic of this video. Let's build another sub. So the keyword sub, give it a name. Now we're going to run, or technically call the open a file macro from within a run my code macro. We can use the keyword call followed by the name of the macro that we want to call from this macro. We don't need to explicitly mention call. I'll just leave it in there for now. Okay, let's run this macro. So I'm placing my cursor between the sub and end sub line, and the file opens. In this setup, I tend to term the run my code macro as the parent sub and the open a file macro as the child sub, which gets called from the parent sub. Now let's look at the keywords public and private. The keyword private before the word sub means that you cannot call this macro from outside this current module. So let's create a new module and just cut and paste the code into the new module. Come back to the first module. Now let's try and run the code. We get an error. And the keyword public, so let's write public this time. This tells us that we can call this macro from any other module within this workbook. So now let's try running the run my code macro. Remember, the open a file macro is defined as a public sub. Hit the play button and the file opens. By default, all subs are public, so we don't need to explicitly write out the word public. Let's cut and paste it back into our original module. Now, let's look at arguments and parameters. We can pass values into the sub. For example, in our open a file sub, we are passing the hard-coded full file path directly into the open method. This is not practical. In real scenarios, our code would be dynamic, meaning that we would need to get the file path from somewhere else. So let's do that. Let's grab the file path from a cell in the worksheet, feed it into a string variable, and use that variable in the open method instead. So we'll grab the full file path from cell B2 in the console worksheet. I'm using the worksheet code name. And now we can pass in the variable name. This will work, but let's unleash the power of VBA. Let's grab this file name in the parent sub and pass down the variable name to the child sub. So I'm just gonna cut this code, paste it into the parent sub. Now we need to pass down the information about the file path that's stored in this file name variable from the parent sub down to the child sub. We need to do two things. First, we need to add the file name as a parameter in the child sub. So let's do that. The parameters will go within these brackets. This is a string value, so we'll declare it as a string. We need to pass this variable name within the workbook's open method. And note that we can pass in any of the following as a parameter into a sub: a variable, a constant, an expression, an array, or an object. And while we're on the topic, let's quickly discuss two ways to add a parameter to the sub. We can use by ref or by val. So before the parameter, we can mention by ref, or we can mention by val. The difference is that by ref will change the value of the parameter that's being passed in through the sub, while by val won't. The default is by ref, but we don't need to explicitly state it. I won't get into this any further. I just wanted to mention that these two terms exist. They are important, but they are not relevant to this video. Okay, so far we've added a variable as a parameter to the child sub. Now we need to pass in the value of the actual file name when calling the child sub from the parent macro. The variable that was declared within the child sub is called a parameter, and the value that we need to pass in here when calling the sub is called an argument. There are two ways we can pass in the argument. First is by using the call keyword, as we're already doing out here. The argument will be the file name variable. When using call, we need to provide brackets. And another way would be to not use the call keyword. And in this case, we need to remove the brackets. Okay, let's try this code out. Play the sub. And the file opens. Great, works well. Now let's push this a bit further. Currently, we're grabbing the file name from within the parent sub itself. Let's challenge ourselves and see if we can grab this file name in another macro, bring in that value into our parent sub, and then pass that file name when calling the open a file child sub. Okay, let's code this out. First, we need to introduce functions. Till now, we have seen a sub procedure which contains code that executes one or many actions. Function is similar to a sub procedure, the big difference being that function returns a value. If we compare the syntax of a function to a sub, we can note two differences. First is the use of the keyword function instead of sub. And second is that in order to return a value from a function, we need to assign the value to the name of the function. We will flesh this out in a bit. Okay, so going forward, we are going to remember the following. If we want to perform a simple set of tasks, we will use a sub procedure. If we want to perform a set of tasks and return a value, we will use a function. I'm purposely not talking about functions from the perspective of making calculations. If you're from an Excel background, that's probably what we would associate a function with. However, functions have a more generic use case than just doing calculations, and this is what we will focus on today. So coming back to our code, we need a separate macro that will grab the file name from the worksheet cell and return the value back to this parent sub. So should we create a sub or a function? And why? I will give you a sec to think about it. Okay, the answer is function. And why? Because we want to return back a value. Let's create a function. Let's copy this code down to the function. And instead of assigning the value from the cell to a variable, we'll assign the value back to the function name. Now let's call this function from the parent sub. Since the function returns a string value, we need to assign the value back to a string variable. In other words, this part of the code will remain the same, and let's replace this with the function. Okay, let's save and run the parent macro, and the file opens. One thing might seem counterintuitive. Our original macro just had 3 lines of code, and we have replaced it with an additional 6 lines of code. This may seem a bit counterintuitive, and for the few lines of code that we're dealing with out here, using child subs and functions might seem a bit over the top. But as your code increases in lines and becomes more complex, these subs and functions will help keep your macro project elegant and manageable. We'll see more of this in the next section. Over the next 2 sections, we are going to convert existing code into separate subs and functions. The idea is that by the end, you will all be experts in creating separate subs and functions. Now, every line of code can be outsourced to a separate sub or function. Here, we have a macro with lots of code in it. We will not be building this macro. Rather, we will analyze each line of code or section of code and ask ourselves, should we transfer this code to a sub or function, and how? And then we'll go ahead and make those changes. This process is called refactoring, where we make small improvements to the code without changing the overall functionality. But before we start, I want to make one thing clear about our objective. This exercise is not about selecting what code or how much code we should be putting into a separate sub. That is a matter of design. But before we even get to that stage, we need to know how to actually transfer code. And with that in mind, we'll be transferring every line of code from this macro to another sub or function. So we may end up transferring single lines of code or parts of a task. This is not always efficient. In reality, we may want to consider transferring larger blocks of code or rather complete tasks. But as I said, that's not our objective. Today, we're interested in how to transfer rather than what to transfer. And the larger goal is to practice as much as we can. Okay, so first let's quickly go through what this existing macro is doing. On a high level, we will copy data from a file on the computer folder given in cell B2 and paste it into our macro into the input sheet. And we can see that the data has 2 different types of dockets. INV is for invoice, CR is for credit. We will save the data related to invoices and data related to credits in 2 separate files on the computer in the folder given in cell B3. And we'll perform the filtering operation using advanced filter. And while saving the file, we'll include the month and the year along with the file type. Let's go back to the code. I have designed the code with the objective of giving us a variety of examples. The comments in the code are demarcations for where we'll be drawing the line for how much code to transfer into separate subs. First, we'll clear the data and add headers for the advanced filter. Next, we'll grab the input file name from the worksheet. We will check whether the file exists. We'll open the file, copy the data onto our worksheet and close the file. We will grab the output folder name where we want to place our 2 files. Here we have some logic. If the output folder doesn't exist, we will create it. And if the folder exists, but if there are already Excel files present in them, we will delete all of them. Our output file names will have the current month and year in them. We will grab these values from the first data cell and then perform some logic, which we'll get into later. We need to grab the data range and copy to range for the advanced filter method. We will call the advanced filter method twice, once for the invoice and once for the credits. In both cases, the data range and copy to range will be the same, just the criteria range will change. Let's set the criteria range for invoices. To determine invoices, we will filter on docket values greater than 0. So that will be our criteria. Then we will sort the data based on the criteria, and then we'll place the sorted invoice data into a new file with the correct file name. And we will repeat the same three steps for credits. Credits are dockets with values less than 0. The point of this part of the example is to show that we don't want to repeat the same logic twice. This is a refactored code which we are about to build from scratch. Yes, we are repeating the steps, but the logical paths or actual operations have been transferred to functions or subs. So the points of failures are the subs and functions which can be managed and tested independently. Of course, all of this can be made more efficient by transferring the entire advanced filter activity into a separate sub, or even do this in a loop. But as I explained at the start, today our sole objective is to only practice transferring code into subs and functions. So this is a macro file. It just has the original macro. I will load this template to GitHub for those of you who want to follow along. We will create two modules. In one module, I'm going to copy the entire original sub as is and just change the sub name to Refactored. And the other module, we'll just leave it blank for now. It will be used to park all our separate subs and functions that we're about to create. So let's come back to the macro that we saw in the previous section. This was the macro where we perform all the steps in the same macro. And our objective is to transfer these lines of code into separate subs and functions. We will work our way from the top to the bottom. And as I said earlier, we will do this Q&A style. I will tell you what needs to be done. You can think and say out loud whether we need a sub or a function, and we'll go ahead and build it. Let's recap what we know about subs and functions. If we want to simply perform a set of tasks, we will use a sub procedure. If you want to perform a set of tasks and return a value, we will use a function. Okay, first we need to clear worksheet values and add header values for our advanced filtering. So we just need to perform a few actions. What should we transfer this code into? A sub or a function? A sub. So let's build it. Let's go to our supporting module. Give the sub a meaningful name. I like to assign phrases, and let's come back to our parent macro. We will just cut our code, come to the supporting module, and paste it in our sub. And now let's call this child sub from our parent macro. You could even use the call keyword in front if you want. So just to clear the terminologies, going forward, we will call this macro the parent macro, and the supporting subs and functions, we will term them as child macros. Okay, moving on. We need to grab the file name from the worksheet cell. So we not only need to perform the act of grabbing the cell value in a separate macro, but also get the file name back into the parent macro. Why? Because we will be using this file name further down in the code. So what should we be building for these lines of code? A sub or a function? A function. Let's build it. Let's go to the supporting module. The file name is text, which is a string data type. Go back to the parent macro. We just need the part where we grab the value from the cell. And let's assign this value to the function name so that we can return it to the parent macro whenever this function is called. Back to the parent macro. Let's call the function, and we can put in an open and close bracket if we want. Okay. This next one is an interesting one. You're probably going to laugh at me saying that the changed code has a lot more lines than the original code, but let's perform these steps and I will give you my reasoning. So here we're trying to check if the input file name that we grabbed from the above step actually exists or not. We do this using the dir function, which returns a blank if the file doesn't exist. In the new version, we want to ask a question. Does the input file exist? If not, then we'll give an error message and exit the sub. So we are only going to transfer this part of the code. And what do you think we should be building? A sub or a function? I'll give one hint. We are asking a question and expect an answer back. A function. Let's build it. Go to the supporting module, create a new function. Now, we want to know whether the specific file name we grabbed earlier exists or not. The function code will be generic though. So the way to achieve this is to pass the file name as a parameter. Let's do that. And as I mentioned before, this function is being built to represent a question, a true or false question. If the file exists, we will return a true and false otherwise. So the function will return a Boolean data type. Let's copy over this dir logic. We'll also have an else condition. If this dir function returns a blank, then the file doesn't exist and the function will need to return a false. So we will assign a false value back to the file name, and else we will return a true. Okay, let's call this function from the parent sub. So when should we return this message? If the file doesn't exist, or in VBA lingo, if not the function value returned is true, then. So if not the function name, we need to pass in the file name as an argument, and that's it. Okay, let's pause and reflect on what we have done. We have replaced half a line of code with 7 extra lines. Does this make sense? Well, depends on what our objective is. My objective when building a parent sub is to try and abstract away or hide away any coding logic. I want to be able to read the parent sub like a page of a book. So I don't want to see the dir function being used out here. The function is simple enough, but sometimes there are more complicated ones. So when reviewing the parent sub, I don't want to worry about what this function is, what returning a blank means, etc. etc. So by building a function with a name that reads exactly like what it's doing, I know exactly what's going on. If I want, I can go down to the supporting module and inspect the function. But most of the time, I don't want the distraction. On the other hand, in the function at the moment, we are only evaluating whether the file exists or not. But we could perform a lot more checks, such as check whether the file extension is wrong, folder is incorrect, and return a false if any of those conditions is untrue. Okay, moving on. We want to open the input file, copy data from it, paste it into our macro workbook, and close the input file. Looks like we need to perform a few actions with our input file. So, what do we need to build? A sub or a function? A sub. And have given a hint, we need to perform a few actions with our input file. So the input file will be a parameter. Let's build the sub. Make some space. Let's cut and paste the code. Cut, paste it in. And we need to update the names of our parameters. So just this right out here. And which reminds me, we need to update this variable name as well to match the parameter name that we are feeding through the function. Okay, back to a current sub. We need to call it from our parent macro. and pass in the file name as an argument. Actually, no brackets. Next, we need to grab the output folder from the worksheet cell. This is similar to the get input file name macro, and that means we need to build a function. Let's go to the supporting module, create a function, let's come back and cut this code. We need to assign it to the function name, and let's call this function from our parent sub. Next, we want to delete the Excel files from the output folder if the folder exists. If it doesn't exist, we will create the folder. We actually don't need to worry about all these steps. Just know this. We need to perform a set of actions. So what do we build? A sub or a function? A sub. And what are we perform these actions on? The output folder, which will be fed in as a parameter. So let's build it. Go to the supporting module. We need to pass in the output folder as a string. And let's just cut and paste in our code. Change the variables. And let's call this sub from the parent macro. And we need to pass in the output folder name as an argument. Okay. Next, we are going to grab the month and year values from the first data cell here in our sheet. The month name and year will form the prefix for the eventual output file name, which means we need to perform these set of actions and return back a prefix value that will be used when saving the files. So what do we need to build? A sub or a function? A function. Let's do that. Again, make some space. Let's copy over our code and assign the value of this concatenation to the function name. Now, before we call this function from the parent macro, I want to highlight one thing. The current date value is being taken from a very specific cell A2. In reality, we should try our best to keep functions as generic as possible. That means they shouldn't depend on any hard-coded cell references, which in turn means that we should have tried to pass in this cell value or the cell reference as a parameter. But for the sake of keeping this video short, I am not going to do that, especially since we are about to encounter this issue many more times in this video. I think from a teaching perspective, highlighting that this is an issue is enough for now. Okay, let's call this function from a parent sub. We actually don't need this line. Okay, back to the parent sub. So let's delete this out and replace our calculation logic with the function name. Next, we are going to filter the data set twice using advanced filter, but in both times the data range and the copy to range will remain the same. So let's build a separate macro to assign both ranges. And what should we build out here? A sub or a function? Remember, we will need these ranges up ahead for the advanced filter method. So we will build a function. Actually, two functions, one for the data or list range and one for the copy to range. Let's go to the supporting module. And we want the function to return back a range. And let's assign the value of this range to the function name. And remember, this function is going to return back a range, which is an object. And when we assign a value to an object, we need to use the set keyword. And let's do the same for the copy to range. Okay, let's call these functions from the parent sub. Control C, assign it to the list range, and Control C, assign the function return value to the copy to range. Okay, I've said this before and I will say it again. This design strategy that we are adopting out here is wasteful. We will end up doing a simple advanced filter operations over several subs and functions. But that's not the point of this video. Today, we're only interested in practicing how to use separate subs and functions. Next, we'll grab the criteria range. This step is going to be performed twice. For invoices, our criteria is greater than 0, and for credits, it will be less than 0. We will build one macro to tackle both scenarios. So what macro should we build? A sub or a function? End goal is to add a filter to the criteria range and return back the criteria range so that we can use it in the advanced filter method. So we will build a function. Let's do that. And we need to pass in the criteria as a parameter. Let's copy the code, paste it in. We will no longer hard code the greater than 0. Instead, we will feed in that text value as a criteria, and we will assign this range back to the function. And let's call this function from the parent sub. We don't need this line since we're doing it in the code. Assign the criteria range to the output of the function. And what are we passing in as a criteria? Our criteria is greater than 0. Next, we need to perform the advanced filter method using the 3 ranges that we have assigned previously. Again, we are going to replace a single line of code with 3 lines of code, but our objective is not to expose the reader of the parent sub to the workings of the advanced filter method. So what do we build out here? Are we returning any values? No. So we will build a sub, but we need these 3 ranges, which means we need to pass them in as range parameters. Let's do that. Make some space. Let's pass in our 3 ranges as parameters. And we can just build out our code using the parameter ranges. Pass in the criteria range and the copy to range. Let's call this sub from the parent macro. First, we pass in the data range, then the copy to range, and finally the criteria range. We will still need to empty the criteria range since we will be using it again. Now, we will copy and paste this filtered data into a new Excel file and save it using our file name with the month and year prefix. So first, let's build a macro that returns the full file name. with the prefix that we determined earlier appended to the word invoices. And in the case of credits, we will append the word credits. We will build a single macro for both scenarios. So what should we build? A function. Let's do that. So the file name will contain the folder path as well. And the prefix that we found via function earlier. And a file type, which will be the word invoices for invoice and credits for credit. And let's construct the file name. So it's just a concat of all these three values. And let's call this function from the parent sub. We need the output folder, the prefix value, and the text invoices as a string. Okay, and for the last bit, let's save the data in a new file. Doesn't look like we're returning any value out here. So we will build a sub and we will pass in the output file name as an argument. Let's cut and paste the code. We need to dim the workbook as well and update the variable name and call the sub from the parent sub. Okay, and we need to repeat these steps for credit invoices as well. So we can just copy and paste over the same code. So it's this code out here. Change the name invoice to credit in the comments. Update the filter criteria to less than 0 and update the string invoices to say credits. Let's save our file and that's it. Again, in reality, we could feed in the words invoices and credits into an array and loop over it so that we use this logic only once to make things more efficient. But that's not our objective for today. And that's the end of this macro. Let's just run it once to make sure that we haven't broken anything. Create that ran and our two files have been generated. Let's come back to our code. Let's just glance over our new and improved code. Everything reads intuitively. The reader is not exposed to any technical procedures or jargon. And we can read it through like a good book, knowing exactly what is being performed at each step. So that concludes this build part. I think you will agree with me in saying that using subs and functions to cut and slice your complex macros is simply awesome. But this is not the entire picture. Using child subs and functions does complicate how you go about adding error handling into your code. So next, let's briefly check out error handling. Error handling in general is your approach to dealing with errors that occur when you try to run your application. And when I say this, I'm specifically talking about runtime errors. For example, let's try to open a file that doesn't exist. In fact, we are doing this right here in our initial original macro. So remember, this is the one where everything is performed within the same macro. Okay, back to the line of code that we were on here. So we are trying to open a file name that we grab from the worksheet cell value. And we have some code on the top to check if the file name is valid. Let's comment it out. So now we're not checking whether the file exists or not before we try to open it. And what we'll do is change the input file name to something invalid. VBA should give an error now. Let's run this code. As expected, VBA throws an error message. Let's hit debug. We enter break mode Generally, we are taken to the point of failure and then we can investigate the issue. So as per our current error, we are failing to execute the workbook's open method. Good coding practice is to gracefully exit your macro when an error occurs. We should avoid entering break mode. If a non-VBA user is running this macro, this would trigger the panic button. But we do want to communicate the error message. The recommended way to do this would be to use a label. So let's come to the bottom of our code. We will add a label here called handle errors. Make some space. A label is like a bookmark in your code. What we will do is tell VBA that if a failure occurs, jump to our bookmark or label. So let's construct this logic so that you follow what I mean. Let's now go to the very top of our code and we will tell VBA to go to the label handle errors when an error occurs at any point within our code. So on error, we will go to the handle errors label. So any code that comes after the on error go to statement falls under the jurisdiction of our error handling logic, which means that now if VBA tries to open the workbook file, it will fail and the code will go to or jump to the handle errors label that is at the bottom of our code, and then it will continue on to execute the next line of code after the label, which is the end sub. So it will basically exit the sub. So on a high level, as of right now, the code would simply exit the sub if an error occurs. But we should at least indicate that an error occurred. So let's alert the user with a message box that an error has occurred by presenting the description of the error. Okay. So one more time, let's go over the flow. When an error occurs, the code will jump to the handle errors label, which is at the bottom, and it will execute the next line of code. So it will display the error message and exit the sub. There is one problem here. When there is no error and the code runs naturally right down to the set WB is equal to nothing line, the code will still continue past this bookmark and try and display the error message. But we don't want that. So in case of a normal error-free run, we need to exit the sub before the bookmark or label begins. Just add in some lines. And while we're out here, I just want to mention that we could add other wrap-up code as well after the label, such as closing any open file, resetting some status, etc. Okay, let's run this macro and see what we get. Remember, our file check logic is still commented out and the file name that we're trying to open is invalid. So let's play. We get our error message and we weren't exposed to the back end of the code. Okay, so that's an overview of error handling for runtime errors for single sub macros. But do we need to change our strategy when our project has multi-sub macros? Let's find out. Let's talk about levels first. In this project that we refactored, we built a parent sub and called several child subs and functions from it. But we didn't call any further child macros from these child macros. We could do that if we want. For example, we could open this file in a separate sub, copy the data in a separate sub, close the file in a separate sub, and call those three subs from this child sub. We won't do that now, but the point is we could if we wanted to. So our current project only goes one level down. This is not a VBA term, but it is helpful for understanding the concept. And following the chain of thought, we could go 2 or 3 levels down if we wanted. That is, when we call additional child subs and functions from our level 1 child subs and functions and so on. This is the potential scope of our VBA architecture. And now our problem is, how do we approach error handling? Let's tackle it. I won't spend too much time here, but I will try and clear the concepts and point you in the right direction. The first approach is what we saw in the previous section with single subs. We can use an on error go to a line label style approach on the parent sub. Let's do that. I'm just gonna copy the code over. So on error, go to a handle errors label. And come to the end of our sub and add our label and message box. Okay. So what is the scope of this error handler? The answer is that the error handling logic will apply to this current level and all the levels below the current level. And since this is a parent macro, this error handling logic will basically apply to the entire project. What does that mean? It means that even if the code encounters an error within a child sub, it will get directed to the handle errors label that we have defined at the topmost layer. That's pretty cool, right? And we can even test this out. Let's come to the clear output folder sub. So if any files exist in our output folder, our sub will delete off each file using the kill command. But the problem with the kill command is that it will throw an error if no file exists. So we have a logic layer on top that checks if an Excel file exists and only then runs the kill command. Now we will intentionally fail the sub. So let's comment out this logic. We'll put a code break at the kill command. Ensure that no files exist in the archive folder. Come back to our macro, go to the parent sub. Let's come down and put a code break at the error message. And let's run our macro. We are taken to the kill command. We know that it's going to fail to execute. Note, we are one level down in the child sub, and the hypothesis is that we should be redirected to the handle errors label in the parent macro. Let's press F8. The code has jumped to the line label as expected. This means that the error handling logic has kicked in. Press F8 again. The error message is displayed. Just make a note of this. It says file not found. Press OK and F8 to exit the sub. Now, there are two important points here. First is that when you're using a parent-child sub style architecture, the minimum recommendation for applying error handling would be to do just what we have done. That is, apply a go-to label style logic at the topmost sub. This will ensure that your macro exits gracefully no matter what level it breaks at. Second is a question, is this enough? The answer is no. If you want a more robust style architecture, what we have done right now just won't cut it. The biggest drawback is that it is difficult to understand where the macro has failed to execute based solely on the error description. For example, our error message said file not found, but which file was it? Was it the input file or the output file? So you see the issue, and this will get more tricky as the macro complexity increases. To effectively troubleshoot, we need to know more about where the error has occurred. This is an important topic, but we have already covered a lot in this video. So now I will just point you towards two suggestions. First suggestion is to apply error handling individually to each child sub. So let's go to the code of one of my previous videos. In this video, I tackle error handling specifically related to sending emails. Here, I've created a child macro to send an email. Its purpose is to simply send an email, but it is structured as a function which returns a false if the email sending code has failed. So this is a child sub, and you can see out here that we have applied the error handler at the child sub level. And at the parent sub level, I ask a question. Did the email sending code execute successfully? If not, then something went wrong, and let's alert the user about it. There are other tips within this code and video. I will recommend that you check it out. Second suggestion is to build a custom error handling function that is designed to reroute your errors. And I have another video which tackles this issue. In this project, I've identified some common error handling scenarios, assigned custom codes to them, and designed a function to alert the user with a custom message that tells them exactly what's gone wrong. And these were just two suggestions. Are these the best suggestions? No. But there is no best suggestion really. It all depends on what you're trying to achieve and how much error handling you're comfortable with. My objective is just to help you strengthen your base understanding of this subject matter. Anyways, that was the video. I hope you learned something new today. Thanks, and I will see you in the next video.